Hello and welcome to the YouTube channel D Creations Resources. We are looking at the concepts from research methodology. Since last few episodes we have been discussing about analyzing the data. Now in one of the prior episodes we have looked at the concept of standard deviation. We have seen its types vis-a-vis population standard deviation and sample standard deviation, etc. Here we are going to make a calculation of standard deviation for a given set of points. Now, please understand that here I am going to make use of each and every point from the given data. So, we are going to talk about population standard deviation, which is denoted by sigma. So, you know that standard deviation is a measure of variation or dispersion between values in a set of data. It's a measure of spread, or it talks about the distribution's extent of stretching or squeezing, right? Now, I think by now you're also aware that if the standard deviation is low, that means the data points are closer to the mean. And if it is high, that means the data points are more spread out. We have also looked at the mathematical formula earlier, and you know that sigma is square root of variance, or standard deviation is the square root of variance. And what is the formula for variance? It is given as summation going from I is equal to 1 to n if there are n points, and this summation is of xi minus mu whole square. So mu is the mean and xi is a data point. So if there are n data points, it will be x1, x2 up to xn. So now let us actually evaluate this for a given data set, and initially we'll do it for a small set, and then as an exercise I would like to give it to you for a larger number of points in a data set. And the solution of course is provided, but I hope that you also do it on your own instead of just watching this video. So let me pause. Get your pen and pencil to do the calculations. Alright, shall we begin? So the data set given is 1, 2, 3, 4, 5. Now how many values are there? N, that is the total number of values, it's 5. So the index I is going to be I is equal to 1, I is equal to 2, I is equal to 3, I is equal to 4, I is equal to 5. Because the summation is going to be taken over this index. So I going from 1 to 5, that is what it means. So let us first evaluate the summation. 1 minus 3 whole square plus 2 minus 3 whole square plus 3 minus 3 whole square plus 4 minus 3 whole square plus 5 minus 3 whole square. It's very simple. 1 minus 3 whole square is what? Minus 2 square, that is 4. Plus 2 minus 3 whole square is just minus 1 square, which is 1. Then third term 3 minus 3 of course will give you 0. Fourth term will again be 1, and the last term, which is basically 5 minus 3 whole square, is also going to be 4. So it is 4 plus 1 plus 1 plus 4. And what is the addition? It's 10. So what have we calculated right now? We are first calculating variance, and in variance we have calculated the numerator, which is the summation, and that has come out to be 10. Now the denominator is the total number of values, which is 5. So variance is going to be 10 divided by 5, which is 2. Now we know that variance is square of standard deviation, or variance is sigma square. So you've basically evaluated sigma square to be 2. So what will be sigma? The standard deviation under root 2. So 1.414. So this is the standard deviation. Now actually you yourself can take different kinds of set points and try to find out the standard deviation. Now logically, if you had taken 5 set points which are identical, so for example if you had taken the number as 1 1 1 1 1, obviously here the mean is 1. So in the numerator you will be the xi minus mu, everywhere is going to be 1 minus 1, it is 0. So the entire summation is going to come out as 0. So the variance is also 0 and the standard deviation is also 0. And now there's no surprise here because you are taking the same number. Obviously, it is not deviating at all. So the set 1, 1, 1, 1, 1, each of the data points is identical as the mean. So there is no deviation. So it's obvious that the standard deviation answer should be 0. Now let us consider a larger set of data points, or so you can see here there are 25 numbers given to you. 1, 11, 12, 21, 22, 23, 31, 32, 33, 34, 41, 42, 43, 44, 45, 51, 52, 53, 54, 61, 62, 63, 71, 72, 81. And please calculate the standard deviation. And as I said, try to do it on your own. Don't just rely on whatever is given here or whatever is shown here. So if you count them, what is the total number? You can pause the video when you are counting and when you are finding out the summation, right? And then cross check. So here the count is 25. If you take the summation just the way we have taken it, I have also shown it here how it is taken. So the mean is going to be 42.2. So whatever sum that you got 1055, if you divide it by 25, you get the answer as 42.2. And then the variance, that is sigma square, you are going to calculate by, in the numerator you will have terms such as 1 minus 42.2 whole square plus 2 minus 42.2 whole square, and so on and so forth. There will be 25 such terms up to 81 minus 42.2 whole square. And whatever sum you get here, I have written it, I have done it myself, and the answer comes out to be 10034. And this you have to divide by 25 to get the variance, which is 401.36. So what is the standard deviation here? It is under root of 401.36 and the answer is 20.034. So this is the standard deviation for this particular data. So you would realize that even though the formula looks complicated, actually if you go stepwise, it is not complicated. So if you are interested, please take some data points on your own and try to find out the standard deviation. Thank you.